Hey folks, welcome back to the Metal Mill 52 workshop. My name is Bill, this is my shop. We've been building an LBSC Tich locomotive, and in doing some tests on it, some running on air tests, I realized I had a problem with my little whistle valve. This is more than just a whistle valve. It's basically the top turret or horizontal turret, whatever you want to call it, but it acts as a manifold that will provide steam to the pressure gauge on one side and the blower valve on here, and also to the whistle. And it has a neat little handle. I covered making this thing in the build series, but you'll see in a second. I'll try to retrieve the first video from the running on air test. The whistle was actuated, and I had to stop the test because the whistle was so piercing. And so, long story short, I had to basically make some modifications to the whistle valve, and I'm really pleased with how it came out. Stay tuned and check it out, because like I said, this one will be useful to you if you're building a Titch or anything, any of LBSC's designs, or anything that involves a little a stainless steel ball bearing for the valve. So I hope you like it. If you do, please give me a thumbs up. Please ask any questions that you may have, and I'll do my best to answer them. Thank you. Well, this is the first running on air of the Titch locomotive. I've got about 50 psi in my little spare air tank here. Getting ready to turn it on. I've not tried this before, so we'll see how this goes together. Well, the whistle, there's no way for me to quit the whistle noise. The whistle sounds great, which I'm ecstatic about, but let me take that tape off. What I'm going to do, I'm going to just remove this whistle line. I'm going to have to redo the seating for the ball on there, but what I wanted to do is at least just capture a few minutes of this thing running on air. So there we go. Alright, the whistle's disconnected. I've got the air charged up again. Let's watch her run on air a little bit. Let me turn this thing sideways. There we go. Alright, it's got about 50 psi. Alright. Cool. And the best news to me is the regulator works just as advertised, and I'm not feeling any extra leaks here, except for that where I disconnected the line for the whistle. So this is pretty good, actually. What I'm going to do, I'm going to cut the camera off and I'm going to reset things. Well, let's run it in reverse. I'll bring you back for that. Now I think I've got the wheels set. I reversed everything, so hopefully I've got them set to run in reverse. We'll see in a second here. Add the air. Yep, we're going in the reverse direction. So other than the leaking whistle valve, and it's not, it's the leak of that, the ball is not seating in there in the top turret. So because I removed the other pieces, I plugged it, but it's clear it's not seating at all. So I'm going to have to rework that to get that ball to seat. But I am declaring victory on the overall running of the locomotive. I'm really ecstatic about that. So next I'll take the cab off, because I'm going to need to, so that I can properly fiddle with the horizontal turret here. And for those of you that are not familiar with steam locomotives, there's always something you got to fiddle with. I mean, even one that's been running, there's little adjustments and so forth. So it's not, I don't look at it as a huge setback or anything. It's just normal adjustments more than anything else. And I do like making fittings. I'm frustrated that fitting isn't working perfectly, but that's life, and we'll adjust and get it sorted out. To ensure that I've got a good seat for the ball valve, and that is so critical for the whistle valve, what I did, I took a 5/32 inch stainless steel ball bearing, and I put it in a 5/32 inch collet, put some tape in there to keep it from rolling all the way through, tightened it down, and I've progressively drilled up to a 3/32 inch size hole, and I've got a 3/32 inch rod in here now. I don't know if you can make it out, but there's some green Loctite on there, so I'm Loctiting this rod in. I'll let it dry overnight. Tomorrow I'll come and I'll cut this shorter so that I can use this as a little, well, I'll show you. I can use it as basically a tool. I've got this time saver stuff from McMaster-Carr. It's a grinding compounds that you can mix yourself with either oil or water. The directions call to mix it with oil, and I use this on the Allen Mogul, on the throttle of the Allen Mogul. So it's powder inside here, it's just abrasive powder, and you mix it up and make a little paste, and there's different grits. So I got the 100 is the very fine. This is they have a set for soft material and hard metals, and it all comes together in one kit that I bought. Man, it was years and years ago, but I saved it because I figured I'd need it again. So I'll do that and machine up that, or not machine up, but clean up, make a better ball seat for that part. Well, I figured out what the problem is with the whistle valve. I took it all apart. That's step one, of course, when you have a problem, is take everything apart and study your parts and pieces. So I've already opened up the hole. This got jammed, the pin got jammed in there a little bit. Opened that hole up slightly so it moves freely, not a problem. We know that the screw and the ball bearing fitting and everything is good because I've adjusted that before. What I should have done, and I failed to do, was examine the place, it's in the back here, where, this probably won't show up on the video, but it didn't take, I didn't even have to put the magnifying glass on. When I looked in there, I was like, oh my gosh, there was all kinds of just little pieces left over from the silver soldering process, which I'm embarrassed to say, but I guess I had just forgotten to clean that out when I must have been in such a hurry to reassemble this. So anyway, I've taken, this is a 3/16 inch flat bottom drill, and I took and used it, just rotating it with my hands to clean out the gunk in the back there. And the next step I'm going to do, I've made a little device here for grinding, if you will. I'm going to use this time saver lapping compound and lap out the inside space there. You can kind of see a little shininess, but to make a nice place, nice hole for the ball. This is what I did. It's 5/32 inch ball that I'll show how I made this on the lathe. It was very simple, but Loctited it to this 3/32 inch steel piece of steel. So we'll use that and the time saver compound here to really make a nice nice seating area for the ball. Mix the time saver with this mineral oil, and it works perfectly. I've done it before on my Allen Mogul. If I can find that video, I'll put a link to it. So that's the next step. I'm going to do some lapping. Spent about 20 minutes or a half an hour by hand with a flat steel rod and the number 40 coarse grit lapping compound to make sure I've got a good sound smooth base there. So now I'm going to put the coarse away, and I'll step up to the finer 3 grades, fine, or the medium, the fine, and the very fine, to polish the place for the ball bearing, the seat. So here's the mixing process. I've got all of the soft stuff is yellow in color, and this is the number 60 or medium compound. So I'm just using a modeling paintbrush to put it out on a little plastic lid, then you cover it up because you don't want to breathe this stuff. I've actually got a little cotton mask on just to be on the safe side. It's freezing cold out in the shop here, so it doesn't bother me to have the mask on. And then I've poured some mineral spirits, pour a little bit more into this cap, mineral oil. And then you just pour a little bit into the mixture. That's about all it takes really, and stir it up with a paintbrush and make a paste out of it. Then I can start grinding or lapping. Just put my Optivisor on and I checked, and it looks like I'm getting a very nice little ball seat in there. You can't see it with this, I know, but I just wanted to show what I'm doing. So that was the first step with this medium grit time saver stuff. So I've loaded up the ball here, and I've got it in, I'll show you, there we go. It's in a handheld drill, and I'm just doing that for a few seconds, well 30 seconds or so, and then checking because I don't want to ruin the part, obviously, but this stuff is pretty mild, and so this is the second go around with this stuff. I also use the paintbrush and paint some down there in the hole, and then to check it, I'm using these little pipe cleaners and wadded up paper towel to clean out the area so I can look and see what the surface looks like. So I'm going to keep going in the process. There's also fine and very fine compound here, so I'm going to use all of those, and we'll see if we can complete this tonight. Turn the light on the video on the cell phone. Hopefully that you can see there's a little ring there, a little rim where the ball seats. I don't know if it'll show up good with that much bright light on, but with the Optivisor I can see it really nicely. So I think I'm getting a good ball seat, and that's just after the medium. I'm getting ready to use the fine and then the very fine, and obviously clean the tool off in between and clean this out. I spray it out with WD-40 and then attack it with a pipe cleaner to get all the remaining grit out of there. Alright, I don't know if this will show up, but this is really awesome. I've just soaked this for 15 minutes. First I rinsed it with soapy water, some Dawn detergent, and then I rinsed it with fresh water, and then soaked it in my pickle, my citric acid pickle, for 15 minutes. Pulled it out, rinsed it again in the soapy water and the fresh water, and now have dried it out, cleaned it out using some clean rags. And I don't know if this shows up or not with the bright light, but I can see a perfect little ball seat in there with the Optivisor. So I'm extremely excited about that, and I'm going to let this thing dry overnight, and we'll put it back tomorrow. Put it back together tomorrow. Forgive the vertical camera here, but what I'm doing, trying to get a good picture of that ball seat after the work with the lapping compound. I'm actually holding the cell phone inside the Optivisor, which is off of my head, and holding it over the part, but hopefully you can see that little ball seat there. I think it looks really good. I just ran a little cotton Q-tip through it. I think it's perfect, so we'll reassemble and give it a test. Now, this is interesting and a little bit embarrassing. When I put the thing back together, and I put a little tube on it here to test to see if I was getting a good seal with that ball. Well, I was not, and I was curious and frustrated. So when I took it apart, I realized it looks like the dang rod is a little bit too long. So as you can see, what I've done is I've just used a magic marker to mark the approximate distance to take off. So I'm going to grind that off and test it again, but here I'll show you what I mean. But this is a clean tube, believe it or not. It's a little piece of aquarium tubing, and the rod is not inside there, so it's just together with the spring and the ball bearing. And I'll show you what I mean here. I'm going to blow on the tube and see if you hear any air coming out the opening there that goes to the whistle. None. So I think the ball is fine. I think the problem is with the rod. So let's take that off and see what if that fixes it. All right, I think we've resolved the issue with the little whistle valve. This is a fun piece to make, and I think some valuable lessons for builders here. But this is a test, the way of testing, real simple way of testing that I learned from my mentor Fred, just blowing on it and seeing what you hear. So I've got a clean piece of aquarium tubing stuck on the bottom here, and I'll cap off the line for the pressure gauge and the blower with my fingers, and we'll leave the whistle line open, and for a minute, and then I'll press the lever, and we'll see if we hear anything. So here we go. So hopefully you could hear air coming out only when I press the lever. So hallelujah, I think we've got it fixed. It was kind of fun working on this, and it turns out the main culprit was the rod, the length of the rod anyway. But I certainly didn't hurt anything, and it was kind of fun going through the process of lapping the spot for the ball, little ball valve in there. I'm definitely going to remember this for future things that involve little balls, rather than the smacking. With a larger pump or something like that, sure, smacking a ball bearing is okay, but this, I thought that was an elegant solution, what I've showed inside this video. So yay. If you like it, give me a thumbs up, please. If you have questions, please ask, and I'll go ahead and put this all back together, and we'll test the Titch running on air again. Thanks, everybody.